Welcome to the examiner's desk. Today, we are targeting maximum marks on one of the most consistently botched questions in chemistry, the giant ionic lattice diagram for magnesium chloride, or MgCl2. Magnesium is a group 2 metal. It has 2 electrons in its outermost shell and must lose exactly those 2 to become stable. Chlorine is a group 7 nonmetal. It holds 7 valence electrons, leaving exactly 1 missing spot in its outer shell. This sets up the foundational rule of ionic bonding. Metals must completely shed their valence electrons, while nonmetals must capture electrons to achieve a full outer shell. Here is the friction point. Magnesium has 2 electrons to give away, but a single chlorine atom only has space to accept 1. If magnesium hands off 1 electron, it still has a leftover electron with nowhere to go. The solution? Bring in reinforcements. Magnesium requires 2 separate chlorine atoms to make the math work. It donates 1 electron to the left and the remaining 1 right, establishing a 1:2 ratio. Pause the video right now and sketch the final outer shells of all 3 of these atoms on a piece of paper based on this transfer. Deducing this atomic ratio mechanically is how you build the chemical formula MgCl2. Relying on memorization often fails under exam pressure, but mapping the electron transfer directly always leads to the right ratio. This diagram shows the correct arrangement of the outer shells after the transfer is complete. Magnesium in the center has an empty outer shell, and both flanking chlorine atoms now hold full octets. Putting the electrons in the right place is only the first step. Students consistently lose marks by failing to encapsulate the newly formed ions. You must draw square brackets around every single ion in the structure. Next, you have to explicitly state the net charge outside the top right of those brackets. The magnesium lost 2 negative electrons, giving it a 2+ charge. Each chlorine gained 1 electron, resulting in a single minus charge. Notice how these charges balance. You have 1 positive 2 charge and 2 negative 1 charges. Mathematically, they cancel out to create a neutrally stable compound. If you submit a perfectly drawn diagram of electrons, but leave out the square brackets and the net charges, the examiner will give you a 0. Both formatting steps are required to prove you understand what an ion actually is. Let's look at the standard high-value follow-up question. Does magnesium chloride conduct electricity? Writing a simple yes here is a trap. You have to specify the physical state. In a solid giant ionic lattice, the positive and negative ions are locked rigidly in place. Without the free movement of these charged particles, a solid ionic compound cannot conduct an electric current. But if you melt it into a liquid or dissolve it in water, that rigid structure breaks down. The ions are free to move. This freedom of movement allows the ions to carry an electric current through the substance. True chemical mastery requires giving the examiner the complete picture. You must state exactly when a compound conducts, in molten or aqueous states, and exactly when it fails to conduct, as a solid. Here is your final checklist for these questions. 1. Outer electrons transferred perfectly. 2. Square brackets present. 3. Net charges written on the top right. And 4. Conductivity stated as yes for molten or aqueous and no for solid. To find your blind spots and test yourself on these exact concepts, head over to studybuddy.tech. You can take a free diagnostic test and access our premium chemistry materials. Approaching the paper with the examiner's mindset ensures you meet every requirement for that top-tier grade. Keep practicing, and I'll see you in the next review.